Welcome into the section on IPv6. We're going to start this section of the course off with a little review of IPv6. Now, if you'll remember, the nuts and bolts of IPv6 was covered in the IC&D 1 exam prep. However, a little review is never a bad thing, especially for people like me who tend to forget what they ate for breakfast today. If you want a more in-depth discussion of all of the concepts that we're going to go over in the next few minutes, then I'd recommend purchasing the IC&D 1 exam prep, where we go into somewhat painstaking detail about all of this. So the first thing we're going to review is IPv6 addressing. Now, as you'll recall, there are three basic classes of IPv6 addresses. There's a global address, and that's just like a public IPv4 address. It is globally routable on the internet. Anyone can get to it. We also have a site local or a unique local address. That's like a private RFC 1918 address in IPv4. And these addresses come from a routing prefix that is reserved for local addresses or for testing. And then lastly, we have a link local address. And you'll recall a link local address is only valid on the segment which it's on. It's not forwarded by any routers. And if you'll recall, when we did our lab over in the IC&D 1 course, when we went to ping the link local address, it actually asked us which interface should I use, because again, all of the link local addresses start with the same prefix. Each IPv6 address has a global routing prefix that uniquely identifies the subnet in question. Once the routing prefix is assigned or created, you can manipulate the last few bytes of the prefix to generate a unique subnet ID. Most routing prefixes that are assigned by internet providers or that you come up with for unique local addresses are around a /48 or a 50, and you can manipulate the last few bytes to get it all the way up to a /64 routing prefix. Now, the last 64 bits of the IPv6 address is the interface ID, and the interface ID is usually based on the MAC address, although you can manually specify what the interface ID is, but in most cases it's easier to just let the device figure it out using the EUI64 method. Now that we've discussed address classes, let's move on to host addressing itself. Now, there are two methods of assigning an address to an individual host. The first is stateful DHCP, and that works just about like DHCP and IPv4 with one exception, and that is that the stateful DHCP server doesn't provide the default gateway or the default router address. The network discovery protocol in IPv6 is responsible for providing the default gateway address. We also have a method of assigning the address called stateless auto address configuration, or SLAC. It also uses NDP to discover the host's unicast address, and then it also uses NDP to discover the prefix and the prefix length, and at that point it goes and asks a stateless DHCP server for just the DNS addresses. Honestly, this makes IPv6 DHCP configuration a lot easier, and I've set it up exactly this way because you don't have to maintain all of the subnet IDs and the default gateways and the prefixes and all that stuff in your DHCP server. All you have to configure are the DNS servers in your network for IPv6. You can then depend on the host to figure out what subnet it's in, what its default gateway is, and where the DNS server is. And last but not least, we'll move on to router configuration. Now, when you're configuring IPv6 on Cisco routers, you'll recall you have to enable IPv6 routing with the IPv6 unicast routing command in global configuration mode. After you've enabled unicast routing, you then configure the IP addresses directly on the interfaces, just like with IPv4. You use the prefix and the EUI64 keyword. The command looks like the sample that's given there: IPv6 address, the routing prefix /64, and the EUI64 keyword. And obviously, once all of the IP addresses are set up, static routes and routing protocols work almost exactly like their IPv4 counterparts. As part of this course, we're going to configure both EIGRP and OSPF on IPv6. You'll see that the commands are very close to the same, the routing tables look almost exactly the same, and the commands are almost exactly the same. It's not really a big leap to go from IPv4 to IPv6 once you get past some of the terminology and that huge IPv6 address that you'll get when you configure your interfaces. And that concludes our review of IPv6.